Welcome to Summarize Science. We often see images of Mars with features that look just like riverbeds and channels on Earth. These features, known as gullies, have led many to believe that liquid water must have flowed on the red planet relatively recently. But a new study throws cold water on that idea, quite literally. Researchers took a deep dive into the physics of Martian ice, and their findings are pretty definitive. The first major hurdle for melting is something called sublimation cooling. On Mars, the atmosphere is incredibly thin, so when ice gets warm, it doesn't melt into a puddle, it turns directly into a gas. This process, sublimation, uses up a lot of energy and actively cools the remaining ice, preventing it from ever reaching the melting point. Think of it like how sweating cools your body down on a hot day. So, the paper concludes that any ice on the surface of Mars simply cannot melt. Okay, so what about ice that's buried underground, protected from the thin atmosphere? The researchers used advanced climate models to figure out where stable ice could exist. They found that for ice to be stable and not just disappear over time, it has to be buried quite deep. Unfortunately, it's so deep that the sun's warmth can't penetrate far enough to heat it up. The daily and seasonal temperature swings only affect the top layer of soil, leaving the deep ice permanently frozen. So, stable subsurface ice is also a no-go for melting. But what if something suddenly unburied that ice? This is the most interesting scenario the paper explores. On Mars, seasonal frost made of carbon dioxide, dry ice, can build up on slopes. When this dry ice sublimates in the spring, it can destabilize the soil and trigger a landslide, or what's called a debris flow. This process could instantly scrape away the top layer of soil, leaving the water ice underneath suddenly exposed to the sun. Could this rapid heating finally cause a melt? The scientists ran hundreds of simulations to test this very idea. Their results show that even in this best-case scenario, melting is extremely unlikely. It only happens under a very specific and unrealistic set of conditions. For example, the ice would need to be very porous, like old snow, while the thin soil layer on top would need to be incredibly compacted, almost like cement. The researchers argue that this combination is just not realistic for Mars. So, let's recap the main findings. 1. Ice on the surface can't melt because sublimation cools it down faster than the sun can heat it up. 2. Stable ice underground is buried too deep and stays too cold to melt. 3. Even if a landslide suddenly exposes that ice, it will only melt under conditions that are considered unrealistic. What does this all mean for those gullies? It strongly suggests they were not formed by flowing liquid water in the last 4 million years. A more likely culprit is the sublimation of that seasonal carbon dioxide frost, which creates enough gas to fluidize soil and cause these debris flows without any liquid water at all. This study paints a picture of a Mars that has been a profoundly cold and dry world for a very long time. It doesn't rule out water flowing billions of years ago, but it makes the recent presence of liquid water very improbable. Thanks for watching Summarize Science.